Hello everyone, Jeb from Jeb's Project. Let's see what we have on the bench today. Hello everyone. On the bench today we have a Fluke 1953A counter timer. Bought her off of eBay. Description on it powered on. And when I received it, it was rattling. So we have to open her up and see why she was rattling. I opened her up. We can see what was rattling around. The OCXO was cover was off, and the OCXO was flopping around. So we'll have to slide that back in there. The foam that was in there is pretty brittle. That's pretty bad. So when I do get it repaired, I'm going to have to put new pieces of foam in, something to hold her steady. But the rest of the board doesn't look too bad. The inside's fairly clean, needs some dusting and cleaning out in that respect. But other than that, everything else looks like it's in pretty decent shape. So let me slide her back together and we'll get her plugged in. Well, she turns on. The eBay description said that it turned on. Well, that it does do. All right, let's see what happens here. We'll plug in my waveform generator, which is set to 10 megahertz at the moment. And as soon as I get her lined up here, there we go. And we have a bunch of gibberish. So the internal reference, the OCXO, doesn't seem to be working. Let's put the external reference on it, the GPS DO, to the external input and see what we get. Okay, well, that's with the GPS DO connected. And the waveform generator is putting out 999.999. So I would say that's pretty close to 10 megahertz. So it indicates that the counter seems to be okay. The rest of the frequency counter, the OCXO, isn't any good. Alright, looks like we're going to have to see if we can see what's going on with that. Well, here's the inside of that OCXO. What a nightmare. This foam is really hard, brittle. Oh, excuse the focus there. So I gotta finish taking her out of there. And the heater works okay. We can get it out of there, figure out why it's not doing its output. I'll be back. Well, a little capacitor down here in this corner, right there, decided to go up in smoke. She released the magic smoke. And I gotta find out what happened there, whether an over voltage, because it's supposed to be a 10 microfarad, 40 volt, according to the schematic. Comes off of, well, it comes through the transformer to the full wave bridge, from the full wave bridge to that capacitor to the voltage regulator on the side there. So maybe it just happened to pick now, decide to short out. Maybe it's coincidental, but I better check the circuit just to be sure. Be back. Sure enough, the capacitor shorted out, and took it out and rechecked it. My short was gone. So I checked the voltages there. I have my proper voltages, about 30 volts in, 18 volts out. That's the 18 volts for the OCXO. And so I guess it was just coincidental. Well, here's the OCXO. And to try to figure out this mess in here, if there's no schematic. So at least I haven't been able to find one. So I'd have to check each component and hope and pray that chip was good. And if when I got done checking all the components and it still didn't work, then I'd have to replace the chip, and it's just too much. instead of finding another one to replace it, I would try to find an original and try to repair this one. It's just going to take too much time. So I had that eBay OCXO that we just got done tuning right there. Now I'm going to use that one instead. I put an SMA connector on it with a cable on the original cable. I didn't have a SMA connector to put directly on the cable, so I used a SMA adapter cable. And then I took my ground from the original OCXO, connected to the ground side of the power plug. The red is connected to a 12-volt supply that's on board. You have a 5-volt, a 12-volt negative, 12-volt positive, and 18 volts. So I was able to tap into the 12 volts right behind this board down near where the original wire is connected. So let's see how she does. Okay, we're connected to the waveform generator, and it's set to 100 hertz. It seems to be working just fine. Let's take it up to 1 kilohertz and see what she does. Okay, right there's 1 kilohertz. And she's reading it just fine. So that's good. Alright, let's take it up to 60 megahertz. That's the highest my waveform generator will do. We'll drop this down. And let's see, there's 60 megahertz. Now, my waveform generator is not exactly right on, but I'm 4 to 5 hertz low at 60 megahertz, which my waveform generator seems to go low in frequency at the higher frequencies and comes in on the lower frequencies. So I don't need to be exact with the waveform generator, but it seems to be working pretty good. Let's go to 10-second gate time. Give it 10 seconds here. And there we go. There we go. Okay. 59, 3. I seem to be 5 hertz. Well, a little more than 5 hertz. 7.5 hertz. Or 6.5 hertz. But with that is 7 hertz low. Okay. You that's pretty decent. 7 hertz low, I'm not going to worry too much about. That's 1 second gate time. But that's my waveform generator. Let's hook it back up to the GPS DO. And it should read exactly 10 megahertz. And we'll bring that up. And she reads exactly 10 megahertz. Let's take it 10-second gate time. She's had plenty of time to warm up now. And we'll see if this thing reads all 9 digits. And there she is. All zeros. That's really good. So the alignment on with the oscilloscope is definitely the way to go. So this thing, I can use this to reference just about anything now. I can trust that the thing's going to give me the correct frequency. All right, now we got to see if all the other functions work. I'm going to go ahead and put her back together and see about testing the other functions. I hope you enjoyed the video. Please like and subscribe, and catch you in the next one.